Okay, so number 33 starts with the,
Just kidding.
does anybody need 33?
I don't know how to number my phone.
Okay.
Yes.
Okay, okay,
No.
all right.
No, nobody needs it. I do.
Okay, so a lot of, we got it. A lot of fancy words here. But really all they're saying is in the following order of pairs, the first element is degrees, so they're going to give you this thing right here. So for part A it says 43, comma, 10. The first number is degrees Celsius, and the second one is Fahrenheit. So if they give you the first number, then you plug that in for Celsius and figure out what Fahrenheit is. If, like in part B, they give you, oh no, part B, they give you the first number again. If, like in part C and D, the number they give you comes second, where do you plug that in instead? For the F, okay? So it's just a fancy way of saying, plug 43 in for C in this equation and tell me what you get, okay? Plug negative 12 in here for C in this equation and tell me what you get. And then this one's a little bit harder, but you plug 12 in for the F and then see what you come up with. Yes? You do not have a calculator. That is tragic. So this is U, comma, 19. All right, so let's walk through these a little bit together. So if you plug 43 in here for C, and you are like Bailey and you don't have a...
I'm Maddie.
Maddie, sorry. And you don't have a calculator, how can you do that without a calculator?
Hit your phone.
How can you do it without your phone?
Your brain.
Right, so talk to me, how do you do this? You guys remember? Can't. Okay, so I'm going to take the fraction and multiply it by 43, so 9/5 times 43. I guess this is tough because they didn't, it's not set up to reduce at all, huh? Not if they're right next to each other, then you multiply the tops together and the bottoms together. I was hoping we could reduce a little bit first. Does anybody know how many times 5 goes into 43? It's a decimal, but 8 point, yeah, you know it goes into 48 times. Yes? Oh, you're going to use your calculator? Okay. So maybe this is more of maybe this is more of a calculator problem. So if you go 43 divided by 5, you get 8.6. And then you multiply that by 9. Jennifer, you have a calculator. What's 9 times 8.6? 57.4? 77.4. And did you add the 32 on yet? Okay, so then we need to add 32 onto that. And if you do that, you get 109.4. Okay, so that's what M equals. Okay? The other way around. Okay, so I'll let you guys work on B by yourselves. All you have to do is plug negative 12 in here for C and figure out what you come up with for the answer. Yes? Yeah, that's what we did. So we went 43 divided by 5. Okay. Okay, so then the tricky one, like I said, is if you are going the other way. I wanted to get that out of the way. So for this, I need to plug the 12 into where we decided? In for the F. So now I'm going to write 12 equals 9/5 C plus 32, and now I need to solve that for C. So what's my first step there? Subtract 32 from both sides. Nothing wrong with negatives. 12 minus 32 is negative 20. Equals 9/5 C, and the 32's cancel. So now here's the $1,000,000 question. How do you get rid of the 9/5 in one step? Multiply by the reciprocal. Good. Multiply by 5/9. So I'm going to take this side over here and multiply it by 5/9. And I'm going to take this side over here and multiply it by 5/9. And the reason that we did that is because since we have a 5 on the bottom here and on the top there, those cancel. Bottom and top cancel, so that leaves us C over there. And then to do this, we can do it just like Bailey said. Go negative 20 divided by 9 times 5. And what do you get from that? Negative what? Okay, negative 36. Did you get the same answer? So you gave us the answer, so how are we supposed to know? Did anybody else get negative 36?
Yeah, I got negative 11.
Yeah, negative 11.1? Okay. So Jennifer, you got negative 11.1 repeating even?
Yeah.
Okay. So what did you do?
I don't know.
You don't know? Okay. Apparently it didn't work.
I will put 9% decimal.
Oh, what decimal did you use?
Straight 1. Yeah.
What's that? Okay, so what you did is you, oh, yeah, that should work.
I did it for the rest of them. It worked for that one.
So there was something else that just
Yeah, you say
screwed up.
no.
Okay.
Yeah, it should be 5-9.
Well, she just started right from here and
Oh.
rewrote it as 12 equals 1.8c plus 32. Is that what you did? And then subtract 32 and divide by 1.8. Yeah, that should work. So you should just,
I did it here.
so you just, yeah, something basic fixed up there. Okay, and so you guys can do B and D now that you understand. All right?
36 and 37.
36 and 37.
34.
34.
Okay. All right, number 34 says, suppose a function pairs items from set A with items from set B. So let's call this set A, and let's call this set B. And we have some sort of function that if you take something from this and put it into that function, it's going to match it up with something over here, okay? So maybe these are colors of socks and these are your shoes, and it'll match up the right socks with the kind of shoes that you should wear that day, okay? So you could have red and gray and white and black, and then this is what color your pants are or whatever. So they're just taking things from one and matching it up with the other one, okay? There's a special kind of function that's called, if it maps a, good morning? Morning. It says if you map set A into map B, that is if the function uses every item from one into the other, okay? So we're going to get away from the socks and shoes idea and say, let's say that this function doubles every number. So let's give some numbers over here. What, does it give us numbers to work with? No? Oh yeah, it's all the whole numbers. Okay, so what are our whole numbers? Okay, yeah, all the whole numbers. 1, 2, 3, 4, 5, da da da, all the way on to whatever. So my function is going to take and pair these up with their double. So 1 gets mapped to what? 2. 2 gets mapped to 4. And then we would have 6 and 8 and so forth. So the question is,
Wait, no, what you could?
and then you could just keep on from there, right?
Yeah.
Okay, so if the function uses every item from set B,
Oh.
so, yeah, I can see why this is confusing. So set B is also the whole numbers, okay? So what they're saying is if you take all the whole numbers and then you double them, will you get every whole number again? No, which ones will you miss? 1, 3, all of the odds, okay? So that means that for part A, the answer is that it mapped it into, okay? Because the answers are in this set of whole numbers, but it did not map onto, because for it to map onto, you have to come up with every single whole number after you did that to it. Horrible explanation. Let's try another one. What's the next thing that they want us to do? Function G maps every number to one greater than that number. Okay, so our new function is, instead of doubling those, it's going to add 1. So if I start with the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, on to forever, and then I add 1 to all of those, will I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, as an answer? No, which one do I skip? 1. Okay, so is that an into or an onto? That's also an into. Okay, does that kind of start to come through a little bit? Okay, function h maps every number onto itself. So that means if I take 1 and put it in the machine, I get 1 as an answer. If I take 2, I get 2. 3, I get 3. Correct. Okay, so that's going to be an onto because every single number in this set is going to be used. All right? And then the last one says it maps every number to its square. So 1 would come out as 1. 2 would come out as 4. 3 would come out as 9. So are we into or onto? That's into, yeah, because obviously we skipped a lot of whole numbers in our answers. All right? So I don't know what that's all about, but there you go. Okay, what am I doing now?
35, 37.
And then is that it?
No. 36. Yeah, you might as well do 39.
Might as well.
Yeah,
Make sure I got the point across and I wanted it.
Okay, so 35 says given the functions f of x and g of x, show that the function f of x minus g of x is constant. How would you find out what f of x minus g of x is? Okay, so I'm going to go f of x, which is 3x minus 21, minus g of x. And the only thing that you have to be careful of, and this does not come into play in this problem, but it will in the future, is when I am subtracting g of x, I'm subtracting the entire g of x function. So what do I have to do notation-wise up here to, yeah, parentheses. So I'm going to put that in parentheses because I want to subtract both the 3x and the 21. Okay? So can anybody simplify that for me? Which is 0. Okay, so the 3x's cancel.
Is it just S there?
So totally gone, and then you end up with negative 42. Okay? Is that a constant function?
Wait, what did it?
Yes.
What did 21
No, and that was the whole thing about this. We're subtracting both of them. Yeah. So it's negative 21 minus 21. So since they're both negative, you actually add them and keep the sign. So my answer is negative 42. How do I know that that is a constant function?
It's a constant.
That's what I'm asking you. How do I know that that is a constant function? I would say this is constant because, porque.
There's no variable left.
No variable, right. It's constant because there's no variable. Okay? So if our answer came out with an x still in it, then that would be a variable function because it has a variable in it. And since there are no variables in there, then we say that it is constant and we have accomplished our task.
What is that?
36. 36.
All right. Okay, 36. Determine whether y is a function of x. And so there's two different ways that we talked about that. One is if you put the same thing in, you'll always get the same thing back. Or the other one is by looking at the graph and doing the vertical line test. So if you want to just start picking some numbers and seeing if we always get the same thing, or should we make a graph? No graph. Don't like the graph. All right, so give me a number.
4. 2.
Okay.
6.
Well, hold on.
8.
Think about it and give me a good number to use. Why did you say 9?
3.
Divisible by 3. Okay, good. So if I choose x equals 9, what's 3 over 9? 1/3. So that's a good one to work with because I can very easily in my head say 1/3 minus 11, hi Janae, is negative 10 and 2/3, right?
Yeah.
Okay. Is there a way that I could put that 9 in and get a different answer than negative 10 and 2/3? I could put a negative 9, but that's putting in a different x, right?
But no, because you'd always have to,
Yeah, I'm always going to simplify, and I'm always going to simplify the same way. So every time I put 9 in there, I'm going to get negative 10 and 2/3 back. If I put negative 9 in there, just for funnies, what do I get from that? Well, this would be negative 1/3, right? So it'd be negative 11 and 1/3, which is different than we got when we put in the 9, but we put in two different things, so that's okay, yes. So can you think of a way that I could put in an x value and get two different y values as answers? Doesn't seem like it, right? So let's take a stab and say that that means yes, this must be a function, okay? And you guys didn't want to graph it, and I don't blame you, but let's just take a look at the graph anyway to see what we've won. 3 divided by x, is that what it was? Minus 11. Okay, so if we had decided to graph it and we looked at the graph there, does that pass the vertical line test?
Yeah.
Yes, and we're kind of missing part of the graph. The minus 11 is down here. You're good with that?
I have a question.
Okay, what's up?
For your board test today, learning target and assessment,
Mhm.
is that something that all the teachers have to do? Or something?
They kind of wanted us to do that, yeah.
Okay, because
And
every
so
school
that's what
teacher.
Mr. Corley did. He kind of walked in and he looked on the board and saw that I had a learning target and then walked out. That learning target is for geometry from yesterday.
Did you get nervous?
Was in the middle of a bad problem that was confusing
I know, you
anyway, so
kinda
yeah, I
like-
kind of got a little flustered,
you
yeah.
chose them.
So now I just have to remember to change that so that when it comes to the next time,
Just put remember and use the instead of mine.
yeah, there you go. Okay, so here's the graph. Can you guys see that this also passes the vertical line test because anywhere I have a vertical line, it won't cross the function more than once? Okay,
Yeah.
so your intuition was correct. Yes, that is a function. Let's take a look at number 37. And that is a little tricky. Let's pick a number to put into that.
6.
6. Okay, that's fine. So let's put in x equals 6. So if I put in x equals 6, what do I do to figure out what y is? I plug it in. Before I get to the square rooting part, what do I have to do to the 6?
You got multiply it to plug
I
it
have
in.
to multiply it by
3.
3, so I get 18. And then I subtract 7, so I get 11, right? Okay, so that means that y squared has to equal 11. And then there were a lot of you that were jumping ahead to the punchline. How do I take that 11 and figure out what y? Square root it? Calculator, what's the square root of 11 approximately?
Whatever it is.
3 point what? 3.3. I have one more decimal just for fun. Okay, so 3.31. Okay, so if I plug in 6, I get y equals 3.31 as an answer. Okay? Is it possible for me to plug in 6 and get a different y value that will work?
I don't understand this.
Well,
Like,
okay.
plug in the same numbers and then all do the same.
Well, that's what we're going to find out right here. So if I plug in the same number again, okay, and I get y squared equals 11, is there a different number besides 3.31 that if I multiply it by itself, I get 11 as an answer? Yes?
Yes.
What is it? Not, oh, I thought you had it.
Negative 3.31.
Negative 3.31. Okay? Because what is a negative times a negative? A positive, okay? So if I go 3.31 squared, I get 11, but so if I go negative 3.31 squared, I also get 11. So if I put in x equals 6, depending on whether I take the positive square root or the negative square root, I could get two different answers. Okay? So do you see how that could happen? Okay, so is this a function, yes or no?
No.
No. And yeah, and the main deal there is that since the y was squared, that's the clue that something weird is going on. Okay? All right, anything else, or is that it?
39.
39?
And 45 and 46.
Oh my goodness.
Just put the 46.
Got all these word problems, huh? Okay, 39, we're doing a little chemistry. The time required for a certain chemical reaction is related to the amount of catalyst present during the reaction. The domain of the relation is the number of grains of catalyst, so that's the first column, those are your x's, right?
Yep. Yeah.
And the range is the number of seconds required for a fixed amount of the chemical to react, so that's the second column. Is the reaction, or is the relation a function?
No.
Why? What doubled up?
The sixes.
The sixes?
Yeah.
We put 6 in twice and got 2 different answers?
No,
No, we didn't. It is a function, right. It's okay to get the same answer twice. It's that when you put in the same x value, you can't get 2 different answers. Okay? So they never did the same number of grains. So as far as we know, yes, this is a function.
But I thought the x was the seconds.
Nope, the x is the first column, the
But
grain.
doesn't the grains depend on those?
I'm not a chemistry major, but it says that they're going the other way around. Yeah, okay. But for you, the next question is, what if they were switched?
Yes.
Okay? So she's looking at it the other way, and she's switching the x's and the y's. Would it be a function then?
No.
No, because of what you said. So now the seconds would be our x's. Once we put in 6 and got 2.5. Another time we put in 6 and got 3. Same input, 2 different outputs. So no, it is not a function.
I put no because then there are these two the same range numbers.
Yes, that's fine.
Oh, this sucks.
Glad you enjoyed.
45.
No,
Okay.
I just don't like not getting.
I know. It's 45, a little mixture of you. Oh.
That's not even funny.
Okay, yeah, we haven't done these for a while. Okay, so a little bit of absolute value algebra here. What is the first thing you want to do to solve this problem? Subtract 19. So your math instinct tells you subtract 19 from both sides. Those cancel. Absolute value of x minus 1 equals 14. Okay, so this kind of relates to the y squared thingy. Can you give me a number that if I take the absolute value of it, I will get 14 as an answer? 14, okay, so I know that the stuff inside the absolute value might be 14, because the absolute value of 14 is 14. What's another thing that I could take the absolute value of and get an answer of 14?
15.
Nope,
Negative 14.
negative 14, good. Okay, because remember the absolute value you think about as the distance from 0. 14 is 14 away from 0, but negative 14 is also 14 away from 0. So if I get this stuff inside the absolute value to equal 14 or, bless you, negative 14, I'm good to go. So what could x equal to make this stuff inside here equal 14? 15, and that's the easy one. Okay, that's the easy one. That's the one you get when you just add 1 to both sides. Okay. What could I get inside here, or what would x equal, I mean, to make the stuff inside there equal negative 14? What minus, what's that? Negative 13, okay, good. So this one actually has 2 different answers. If x is 15, it'll work, and if x is negative 13, it will also work. She's having fun. All right, was that it?
46. The big timer.
46, the last one?
And 52.
Oh my goodness, you guys are wearing me out.
We did 50. Yeah, I didn't get 46. I didn't do 50.
I didn't get on the other
Okay, 46 is a 2-stepper. You girls in the back, Carly, Megan, and you guys gotta pay attention, okay? First step,
I know.
well, let's say it.
You got
You subtract 2. So these 2's cancel. Remember the negative sign stays with the 3x. 11 minus 2 is 9. Okay, divide by, nice. Good, so since I'm dividing by a negative number, my final answer is not x is less than negative 3. So flip that around and say x is greater than negative 3. Good, so that's the point of that, so just make sure you remember that little piece. And then 52 is real easy. This relates to one that we did already today. if I have 3/4 y equals 15x, and I want to get the y by itself this time, how do I get rid of that 3/4? We already did a problem just like multiply by the reciprocal. Good. So I'm going to multiply this side by 4/3, and I'm going to multiply this side by 4/3. 4's cancel, 3's cancel. What's 15 divided by 3? And 5 times 4 is 20. So survey says 20x. Okay? Whew, that was a lot. All right. Turn those forward, please.